In the example here, we're going to be using the continuous change model as indicated by the fact that we're told that the amount is going to be compounded continuously. So that's our A equals PE to the RT power. And so the 10,000 is going to be our initial investments. That's our P. Our rate is going to be based off of this 7%, but we're going to have to express that as a decimal. So it's going to be 0.07. And then our T, our period of time for this investment, is 10 years. So in our equation, we're going to have 10,000, the original amount, times E to the 0.07 times 10. And so we're just in button pushing territory on our calculator. And so if we multiply that out, rounding to the nearest penny, as we should for dollar amounts, we've got $20,137.53. In the second example, we're looking at a comparison between what you have in your college account that's described by the graph here, and your horrible twin sibling whose account is described by the equation given here. So we're going to be jumping back and forth between these two, reading from the graph and then using the equation. So the situation is you both have college funds that are started when you were born. One is described by the graph, that's yours, and then your siblings is by the equation that's highlighted there in red. So we want to start off and figure out how much was originally invested into each account. So for you, we're looking at the graph, and so the original amount is going to be when t equals 0, so that's the point at which you're born. And so we can see that the starting point in the graph is this 0, 4,000 location. So that means for you, your starting balance was $4,000. For your sibling, we're going to look at the equation. And so if we recall the number that's in this spot right here in the equation, the p value going back up here, that's going to be the initial amount that was invested for your sibling. And so for whatever reason, your parents loved them more, they gave them $4,500 to get started. So now we want to see what's going to be the case after 12 years. So by the time you're 12 years old, starting middle school, what is the balance of your accounts? So again, for you, we're just going to refer to the graph. And so we've got this spot right here that we can highlight. So we're looking at year 12 on the graph. So we're not going to get an exact value, but we can see we're a little bit above 8,000. We're definitely not halfway up to 9,000, which would be the line above it. So we could estimate it to roughly be maybe 8,200, 8,300, something along those lines. We just want to ballpark it. Because now we're going to compare that against what your sibling has from this equation here. So in the case of your sibling, we're going to do similar to what we did up above. So we've got the 4,500 as our initial amount. We've got e to the 0.04, and now we're going to plug in 12 for t since we're looking for things at the 12-year mark. So if we go to our calculator and push buttons for that, we're going to find that your sibling clearly is not getting as good an interest rate compared to what you're getting in your account. So we get a total of $72.73. So $7,272.33. So thankfully, even though your parents gave more to your sibling, you ended up with an extra almost $1,000 because clearly the interest rate in which your money is invested is performing a little bit better than that of your sibling.